I like using a rotary burr for my last finish on most applications for welding and brazing, because you're getting rid of grit that actually comes off of your grinding stone and embeds itself into your materials. So by taking a rotary burr and doing your last coating over there, you're probably getting less grit than if you just left it alone. Just my thinking. Okay, here's another thing I find on casting. I'm just going to fill this up with casting, so why should I go over the edge? Well, this has got corrosion and dirt and everything else along that south side. If you want a good bond right along your last leading edge right there, you got to get this clean on the outside. Take and give it a little rollover so you don't superheat the leading edge, causing a crystal formation of the cast at that point. Alright, now we're ready to add material back in there. Alright, we're cooling down now. We're taking a tap and we're just kind of chasing out the 3 good holes we have, because we're going to start putting the bolts in, taking dimensions, and we're going to figure out, and we're going to go in and set it in on the 2HL mill, because we got the 90 head in there, and we're going to zero in, come in here, and we'll skim the face of that with the an end mill to flush it out with the rest of the surface here, and drill and tap it. We're about 700 deep here. What we measured on the other 3 holes here. They're all coming about the same. I marked it with a Sharpie here and then took it out and measured the depth. Alright, the flange face of the turbo is bolted down to the table, and we've got it cocked back and forth until we got it within 2 thousandths as far as the face run out. And now we're going to go over and we're going to dial in these holes and then come over and grab 0 or center crosshairs of the bolt we need to drill out. Okay, we put a 1/4" dowel pin in here, and it moves around, and we can see we get a little bit of motion, but there's enough spring tension on this indicator, and as I rotate it around, it does move that dowel, but it maintains within 1/1000. And I have gone plus and minus, up and down, and in and out, and it's an average of being 0 with that hole, and we're going to call that 0. Now we're just going to go straight over 3 inches, 350 thousandths, which we've proven is hole to hole square, and we'll be ready to drill. Alright, we're just double checking our hole center here. We got 3 inches 661 on the highest spot. Okay, let's check. We're checking the stock holes here first before we go over to that one. Okay, and we got 3 inches 658. 3 inches 657, 58. 3 inches 663. Well, we got a little bit long there, about 3-4 thousandths long, but it's right in parallel with there, and I don't think there's any flies on that. Now this could have been worse. This was exposed all the way out here. You saw how I was able to grind on that. But what if it was that one, that short one, in next to this cavity right here? That would be a very difficult spot to braze in, because you wouldn't have a nice access to get to the full depth of that thread there. So I mean, it was lucky that it was that one there. We probably would have figured out something else, but it was pretty straightforward, pretty simple procedure there. And of course, the turbo is still spinning nice and free. There's no grit grind. We didn't get no dirt inside there, and we didn't excessively heat it. I mean, we put a enormous amount of heat on here, but the amount of heat that transferred back here, because we had the blanket choked in around here, and acted pretty quick. We had to wait for it to heat up, but we acted quick on it. So much for breaking something off in your hole there. I mean, this is only one piece, a single rose here. We didn't have a bouquet of bullshit in there, and you know, hey, you know, saving it, that's the name of the game. Get her done.